You're breaking into somebody's system.
No, go ahead.
I mentioned in the 526 to 590 class, we have a number of very interesting speakers lined up in the coming weeks. In particular, in 3 weeks, we are having not only a speaker, but we're having a series of other presentations as part of our first annual research symposium for CERIAS. And you are welcome to attend that. We are going to have on Thursday afternoon, the 20th, we're going to be having a poster session and some demonstrations. Some of you are present will be presenting, and you may not know that yet, but you will be. And then on Friday, Friday the 21st, we'll have a series of talks by faculty associated with the center on some of the research projects that they are involved in. The day will start off with a talk by Martin Sadler from HP Bristol Labs on security of .com walls. And at the end of the day, Mike Jacobs, the Deputy Director of the National Security Agency, will be giving the closing talk. All of those are open. All of those are available to you if your schedules permit, and we certainly encourage you to attend. Is that? Okay, one other announcement about the class. If you signed up for this class for Pascal credit, then hopefully you've been signing the attendance sheet every week. If you didn't sign up for this, then you don't need to worry about it. If you think you signed up for this for letter grade credit, there's a problem. So you better see me, because it isn't offered for that. And if you have no idea why you're here, then I guess that's Friday afternoon. I know why I'm here. I'm here because of our speaker. And when you work in security for very long, especially in recent history, you go to a lot of the same conferences and see a lot of the same people, and you see a lot of the same names occurring. And for as long as I can remember, I've been saying Padgett's name.
I've been seeing yours for longer.
Okay. And no matter where I go, there I see Padgett. And I've been to a doctor, but it hasn't helped. Padgett has been active on the scene of information security, particularly applying information security in a reasonable way, which is important, more than theory. For a number of years, he has indicated that been working in this area for effectively 30 years in some respects, or you've been?
No, I've actually only been working in, well, it depends on how you look at it. My first paying job was in cryptography.
There you go.
But that was 30 years ago. I actually got into security by accident in 1989.
That may or may not find its way into the talk, but Padgett's been involved for a long time. He is currently one of the principal security architects for Lockheed Martin Corporation, a very, very large corporation with a lot of security needs, and they are one of the sponsors of the CERIAS. Padgett's been involved in that area for a long time. In addition to all of the work he does going from airport to airport as part of his job, he also collects Pontiacs. And I'm not sure if that will find its way into the talk either, but it's going to be an interesting talk on issues of malicious mobile code. And so please join me in welcoming Padgett Peterson.
Thank you. Well, actually, if you're involved in security for a long time, you find out there are a lot of people who really don't want any. Second problem being, if you do your job right, nothing happens, which makes it difficult to be a hero. In order to be a hero, something's got to go wrong. So I try to avoid confrontation because I'm very lazy myself. I find it a lot easier to put defenses in place before things happen rather than trying to clean up the mess afterward. But that doesn't make you a hero. So occasionally I feel the need to strike back at the world. And there is absolutely nothing like 400 horsepower and a 4-speed to do that. Though I imagine there are few of you who here today who have had the advantage of such pleasures. We're going to talk about malicious mobile code on the Wintel platform, which is another way of saying PC viruses, because everything's a virus today, right? It started out being infectious code, but then the media got a hold of it and it became everything. But it really has a long history, and if you follow the evolution of mobile code, particularly malicious code, you follow it, see it follows certain patterns. The beginnings, really first one was Core Wars in 1957, long before there was anything that would affect the name virus. Now the interesting thing about it was designed to run in mainframes that had memory allocations. And Core Wars would have two opponents, each program jumping around in memory into different places. And the point of Core Wars was for one code to overwrite another program while it was trying to process and destroy it. Now this sounds like innocent humor, right? I mean, it's a fun game for 1957, back when everyone drove Dodges and had refrigerators. Never mind. But what the point was, this was an early multitasking. And people would be playing Core Wars, and all of a sudden the database application would fail because the core programs had punched a hole in the application. They weren't supposed to, but they did. And this has been a common trait of malicious code, whether intentional or not, ever since then. Two factors about viruses. One, I have never seen anything done by a virus that could not be done more efficiently without one. Okay, second factor, even the viruses that claim to be benign foul something up. Even programs that are supposed to be infallible, one of them. I mean, I remember the early Jerusalems, and they said, well, except on Friday 13th, they wouldn't affect anything unless you were running Volkswriter, which expected certain aspects of the program to be in certain places in memory. And if it got infected by even a benign virus, the first thing that happened would be the thesis on your floppy. We only had floppies then. We didn't have hard disks yet, or the people who did have, what were the first 10 meg ones? $3,000? I mean, this was a PC. You wouldn't believe the cost of a PC in 1983. So the first thing that happens is Volkswriter overwrites your thesis. Now, is that a benign action? I mean, this all commonly happens. Okay, 1984, it became real, at least mainstream in the thought of it being published in Scientific American. What, September issue? September, October? Somewhere in there. Someday I need to look it up, but I haven't gotten around to it yet. This is before you had online lookups for everything in the known world. You know, there was a time before the internet, people. A lot of us grew up in it. But at any rate, 1985, Fred Cohen defines the word virus as propagating. And the interesting thing is, Fred defined the word virus mathematically and programmatically on a VAX 11750 at his alma mater, after which he was given his doctorate and told never to touch the institution's computers again. A common problem with virus people. First really effective one where I got involved was 1986 Brain, though I got involved in 1989 when it really started to spread. One of the interesting things about viruses is typically they are detected months or years before they really spread. We are starting to see a change in that today, but for years we would have a lot of time between the time a virus would appear and the time it actually started getting anywhere. That is, provided anyone was looking. In fact, I first became aware of Gene's original work on the Morris worm about that time. And if you ever really want to know why it didn't work, he is the expert on it. You wouldn't know it to look at him, would you? But that was code that was never supposed to affect anyone. In fact, it was, when you look at it closely, it's a mistake in the code that caused all the computers to go down in 1988. It wasn't intentional, but it was collateral damage and very real damage. Now, how does something that happened in 1988 relate now? Well, in many ways, Melissa did exactly the same thing. It spread in ways even its author probably never expected it, because I suspect he never had seen a very large global address list and what would happen in that case. So this really does have bearing on today. But 1986, with Brain, I was working at the FAA on the National Aerospace Plan Network topology, which was something totally different in 1989. And they got massively infected by something. And it turned out to be the brain virus. And looking at the brain virus, I saw, well, okay, this is something that's grabbing 3K out of the top of memory, so let's just look for memory mismatches. Now, for those of you who, anyone here ever do any machine coding, really studying? Oh, good. Then you know what it means to know how much memory you have. And if the bias says you have one amount of memory available, and the operating system says, no, you've got something else, wouldn't that tend to make you a little suspicious that something strange was going on? To determine that requires just looking at 3 bytes in an IBM PC. I'm not talking about Windows, I'm talking before Windows. But even today, boot sector viruses and 80% of the known viruses could be detected just simply by how much memory you got, does it match? That simple. And yet we got a multi-million-dollar industry built up and lots of wannabe virus writers that still use the same exploits simply because that technique was never properly utilized. Minor things. Okay, Jerusalem appeared in 1988, 1999, was most commonly spread on networks. I mention that in particular because that was the first really large spread, fast large spread, 2,000 nodes infected in under 3 hours. Why? Because it got into the login sequence of a network. Now, the interesting thing was there was no defense against that at the time. But it was very simple. What do? Well, you clean the server and you put something else in the login sequence to find out if the client who's trying to connect is infected. Simple, right? I mean, it was fairly common for about a year, then it disappeared. Why did it disappear? Why does technology fall by the wayside? Well, you could say for one reason, because it's something you can sell once and you'll never make another dime off it. If you look at the popular answers today, they are ones that you have to install a new set of files every month. And not the ones that just simply detect, well, did something change? If so, what was it? Those programs never succeeded in the marketplace. I never have really understood why, with one very interesting example of one that did survive. Your own tripwire, which is an integrity manager. It disappeared from common use, but it did survive with commercial people who understood the implications. Concept, 1995, first macro virus. Now the interesting thing about it was Concept all it did was pop a window with the number 1 and spread. That's all it was supposed to do. In fact, the rumor is that it was developed by one of the original Word 6 programmers to say, this is vulnerable to this sort of thing. You really don't want to make it available. Now, the interesting thing about it was it only really worked on a PC. It could infect a Macintosh, but not well, because Macintoshes were different, even though Word ran on both of them, Word Basic ran on both of them. But then Microsoft put out something called ScanProt, which, aside from the fact the only virus it could remove was a concept, was an absolutely marvelous tutorial on how to make something run on both a Macintosh and a PC. So if you put the two of them together, what you got was, by 1999, macros were the most common form of virus seen. Now, the interesting thing about that is that these macros are very easy to detect. Ask Word. It will tell you if a document has macros. Now, the fact that they are macros, when a lot of antivirus people got together in 1996 and said, well, gee, macro viruses are a real problem. Only a few people, mostly businesses, but only a few people are actually using them. So why not give the user an option to turn it off? What? Disable our product? This becomes more obvious a little bit later. But it's made possible by Word Basic. And in fact, Melissa spread exactly the same way. It did some novel things. I mean, doesn't everyone want to send email from inside their applications? The fact is, I have never seen any use, particularly from inside Excel, of collaborative data objects other than by viruses. But it's considered a very big selling point. In fact, if you look at the, let's see. Oh, that's not the one. Let's see which one this one is. Oh, well, let's skip a little bit. If you go out to the Microsoft website and do a search on collaborative data objects, you will be absolutely amazed at how much it will tell you about how to send email to everyone in the known world from inside Excel. I mean, absolutely wonderful information. Now, we then get into the Russian New Year, 1998. The reason I mention that is this was the first one, even though it never really spread, and I think it's just because it is a rather complex action, and the only people who actually looked at it were ethical enough not to exploit it. But then again, the next really drastic effect may be it. Was the Russian New Year. It used pure HTML in messages. It didn't, the reason this is important is it didn't require an attachment. Concept spread as an attachment to email or as a file sent between people. Melissa spread as a Word attachment to email. Even though it would use email to spread itself, it was an attachment. Russian New Year used HTML natively, scripting language. And that's what I was trying to bring up. This case, which has since been corrected. Now, the interesting thing about this, the Russian New Year exploit was made known among the vendors in 1989 or 1998, right at the start of the year. Almost immediately, Netscape filled the hole. This does not work as Netscape 4.0 or later. However, the other vendor, for reasons known only to themselves, never did do anything. Well, not entirely never did anything, I should say. This works because the it used an iframe mechanism with a source of, in this case, an XLS. Now, anyone here write HTML, you know you don't create a frame of a spreadsheet. You use a frame of an image or more HTML, which may have menus in it. But this is part of the reason the Justice Department got very interested in Microsoft. Because it turns out that Windows 95, 98, or 98 started it. Windows 2000 continues it. Millennium has it. Has a single-threaded mechanism for handling what they call Visual Basic, VB or VBA, or VB scripting, which is a subset of it. There is only one element within the operating system, so it is considered part of the operating system. So in order to get toolbars in Word, they had to include Internet Explorer because that was the mechanism that contained the Word basic handling mechanisms. So the same mechanism you use for Internet Explorer to process web pages was also used by all other Office applications. Word, Excel, Access, PowerPoint. Do you know you can put a PowerPoint virus? You didn't want to know that, did you? But the thing of it is, it all uses a single-threaded mechanism. So once the VBA segment gets it, it's no longer looking for a frame or a web page. It's just looking for something understandable by some Office function. So what happens is, instead of opening a frame, which would be floating normally, it punches that onto Excel and opens Excel in the background, and if Excel happens to have the right XLS with macros in it, guess what executes? Now, the really interesting thing that was discovered is that if it was launched from inside Visual Basic, it skipped all macro checking. And if you ever saw the Word and later XLS patches that came out, they simply closed that hole that would trigger a warning in XLS and Word, so that you get a warning flag that says it's starting with a macro, your normal macro warning. They did not do anything to keep an XLS from being inside an iframe. So you talk about interesting point failures and addressing the wrong thing. So as far as I know, there never was a patch for PowerPoint if anyone wants to play with PPT files. Now you see the mechanism used for there. It's simply native HTML. Now, the scary part of that is, even today, almost nothing looks at the actual contents of a file. It looks for attachments. It looks for malicious code in attachments, but not in the text of a file. And in this case, that text is where the actual problem lies. Oh, let's see, is that... There we go. Okay, Melissa, I figure decides a space of its own. Occurred last year in March. Surprise success. Why did everyone get so excited about Melissa? Well, speaking from someone inside one of the corporations affected by it, I think you'd be surprised at why. On the 26th of March, a year ago, which is almost exactly a year ago now, all of a sudden our mail stores got filled. Microsoft announced there was a new virus floating around that on infection would send out 50 mail messages. Add a zero past my hand. Right? Everybody remember that? 50, right? How many people think that was a real number, 50? Anybody? I mean, you all studied the code? You know if there were actually nested do loops in there?
We just don't trust Microsoft.
Yes, but the word from Microsoft with the same program that detected the files and cleaned out the message stores was 50 messages. We had 100,000 infected messages sitting in the stores. Now, to a corporation, the first thing managers learn is how to multiply and divide because you needed to figure percentages. So, 100,000 infected messages. Each infected machine sends 50 messages. How many infected machines do we have? 20,000 in a population of 160,000 coming from every site in the company. Shut it down. And they did. Now, thing of it is, there were nested do loops in there. And hitting the right global address list, and we've taken steps to fix this now, at that time would send out not 50 messages, not 500, not even 5,000, but one broadcast could send out 50,000 messages. So how many infected machines do we really have? Another thing they didn't bother to tell us was only Outlook 98 was affected. And at that time, we didn't even allow Outlook 98 in the corporation. However, there were 2 people. But that piece of information didn't surface till almost a week later. So why was it a surprise success? Well, one, it spread like mad. It was very good at spreading. But it didn't take much. And what made it such a problem for corporate America in the days that followed was not that the virus itself was so much of a danger, because really it wasn't. In anything other than Outlook 98, it was a fairly boring macro virus that we knew how to handle. However, in Outlook 98, it spread drastically. But we didn't have that information. And this is typically what occurs anymore. We don't have the information when something hits. Let's move forward a little bit. Bubble Boy. Anyone hear of Bubble Boy? Caused a panic for almost a day and a half. Why? Because it was HTML enabled. Nobody'd seen it yet, but it was an HTML. What it did was it was embedded in the text of a message. This was late 99 now. And by this time, enough Outlook 98 and HTML enabled mail readers. Anybody know how many HTML mail readers there are? Eudora is 5.0. They don't talk about it too much because it doesn't do the same things, because it isn't as intimately connected to the operating system, so it acts differently. But this was a panic for almost 3 days, and was very interesting because it was a scripting function. Let's see, I believe I have it here, if I remember which one it is. Is that the one I just took? No, that's executable ASCII. Anyone ever hear of executable ASCII? Would anyone care to guess what executable ASCII would be? No, no, no. No one wants to venture one. That's executable ASCII. Anyone ever see the ICAR test string sent out with a number of different antivirus products? Well, let me give you a hint. In the 93, 94 time frame, there was a lot of belief that you could not send a virus an email. Okay, because it can only send text. This is before attachments. Well, it turns out that there are two RFCs, 821 and 822, or is it 921, 922? Anyone remember? One of them. 821. That defines SMTP email, Simple Mail Transfer Protocol. And 822 is the one that defines the character set that may exist within it, which is essentially ASCII printable characters. I mean, why would you want to send something that wasn't a printable character? What that is if you take the ASCII printable set, and I know some of you are going to be fascinated by this concept, it contains enough instructions and data constructs for the Intel processor to create a complete and self-sufficient program, including termination, which turned out to be one of the more difficult pieces. There is enough within that subset. And what you are seeing there is an executable program written entirely in ASCII. 1993. That also uses something that Microsoft said, that particular one, that Microsoft said it couldn't be done because they said, well, we created ActiveX, and yes, we put create object and get object in there, but it's only good for text. You can't send an executable that way. Guess what? Something only can't be done until someone does it. Computers are made for people to discover new ways to use them. And the only way to really understand the security implications is to really understand what the computer is capable of doing. Start from the microcode level, work up. So Bubble Boy, which I've got the text, I can show it to you a little later. I want to leave some time for questions as we go along here, was HTML enabled, and it used a quirk of that same text mechanism to drop an executable file using nothing but VBA script. And now, you might say, so you drop a file. Big deal. Somebody's still got to execute it, right? In Windows, do you know what happens if you put a file into the startup directory, the start menu directory? This is why you got to wait for the next boot. How often do people boot Windows? So it exploited, and that second part is the really interesting piece. Bubble Boy came out late in 1999. What came out early in 1999 was, and I know I saw it here, where'd 032? There's 032. Microsoft Security Bulletin 99032. For those who are interested, in 1998, there were a total of 18 security bulletins issued by Microsoft. In 1999, there were 61. So far in 2000, we're up to 19. Does this give you and the only time they issue a bulletin is, one, there's a serious vulnerability, not just a vulnerability, something that can be exploited. And secondly, one that they have a fix for. But at any rate, vulnerability in ActiveX controls, and this was also known as the Type X and iDog. Now, one of the interesting things about controls in the Windows system is Microsoft has this undocumented feature called Safe for Scripting, or Safe for Execution, which a program may take on. And it turned out that out of the 115 different controls that are marked safe for execution, 2 of them could be addressed directly from a web page. And anything that can be addressed directly from a web page can also be addressed directly from an HTML-enabled mail reader because they follow the same sequence of operations. Fortunately, we haven't seen too much of this. But so we have the case of a bulletin coming out in mid-99. And has everyone installed this patch? Had any of you ever heard of this patch? One person. There are some people who follow. If you really want to look at www.microsoft.com/security, and you can get direct links to all the bulletins. For instance, there was a patch for the Russian New Year vulnerability, the XLS and the docs, right? That was for Office 97 because you had to have Outlook 98 and Office 97 running. Okay, so they had this patch. The patch was, it was about 100K or so, except for the fact that in order to download the patch and install it, first you had to have Office 97 Service Pack 1. Then you had to have Office 97 Service Pack 2. Then you could install the XLS and doc vulnerability patch. Okay, got that? 100K for the patch. Any guesses how big Service Pack 1 and Service Pack 2 were?
Same size as the application.
Would you believe 32 megabytes to download on a 9600 baud modem? Right. So, we have a bulletin. We have a fix, which no one ever heard of. And we have people who read the fix. Guess who reads the fixes? Oh. So we get Bubble Boy. Now, fortunately, and I say very fortunately, this happens a lot with virus writers. And I'm not sure if I should tell this secret to you, but I will. Virus writers seem to believe that their machine is identical to every other machine in the known world. Let me tell you, they're not quite right. Bubble Boy required specifically Outlook 98 and IE 50, and it came out in late 99. How many people had IE 50 in late 99 who were also using Windows 98 with preview pane turned on? Yes, exactly. So fortunately, it didn't work. Now, any guesses how well something like that would work today? Now that many more people have the latest software. Or in fact, that was one case where I had something that is very common to people who study viruses a lot. It is looking at the virus code and thinking, gee, if they just did that. You're very fortunate because the people who write antiviruses won't. And that is probably what is saving the world from a slow death by computer. Because when you look at the systems and realize just how vulnerable they are, it is scary. Fortunately, there's no tactical advantage, and most viruses are... Anyone here do a ham radio operator? Not too old for you? Know what a QSL card is? Most of the attacks are essentially people counting coup. Know about that one? Showing they can. Where damage is done, it's usually because they did something to a system they didn't understand well enough to know what to do without bothering anything. And I guarantee you that any code sequence you can imagine, even 90 no-ops, I can find you an environment where that's destructive. Does buffer overflow come to anyone's mind? Just by existing, just like the core wars damage done originally, it's going to cause damage somewhere. Okay, why limited success? Why don't they work a whole lot better than they would? Why? Well, there's some reasons. Specialized environment. The people who write these don't have a broad knowledge of computing environments. Now guess where you can get the best broad knowledge of computing environments I've ever seen? Either a corporation or a university. You know, fortunately, people who write viruses don't tend to think that far. Really, that they're not only limited in ethics, they're also limited in thinking. It is much more difficult, and this is the reason why I say you can't write a benign virus, to write a program that will operate well in almost any environment. Consider executable ASCII. Like I said, one of the most difficult things was to make it terminate. And the reason it was difficult to make it terminate is because you had to do some self-modifying code. Computer science people can close their ears. I'm talking about something every professor tells you not to do. But sometimes it's necessary to accomplish what you're trying to do. In order to have self-modifying code work, you first have to flush the cache. Now, that sound easy? Flush the cache in everything from an 8086, 8088, 8186, 286, 486, Pentium 1, Pentium 2, Pentium 3. That is an interesting challenge because it means you have, in order to write the code, you have to understand all those architectures. Now, it used to be you could just go to Intel and they would give you all those books. Now I have some that are considered collector's items. In fact, the one I used most when doing early antivirus work was a preliminary data manual from Intel dated 1979 on the 8086 architecture, which included the complete instruction set in timing diagrams and information on how big the cache was and how to flush it. Sometimes, like engineering, writing good code is really a boring process, particularly if you want to work on very wide mechanisms. We see a lot of companies today that can write code that works once or in one specific application. Writing very broad code is very difficult and not for the mind. So why do they have limited success? Well, probably they didn't know that they were being specialized because they weren't aware of all these different mechanisms. Worked on a single platform. Another factor, there was very quick reaction. Unfortunately, in some of the cases, the media got a hold of it first, and the media is always wrong. Not entirely wrong, just wrong in subtle places. And I remember when the little black book of computer viruses came out, it was how to write viruses. And it included program viruses and boot sector viruses and various descriptions. For instance, the boot sector virus only worked with DOS boot sector from version 3.3. would not work with version 4.0. Why? Well, the registers are different at the conclusion. But if you knew that, you didn't need the book. So one of the big problems with the media we get is that the people who can recognize the errors didn't need it in the first place. The people who can't read the errors, well, 10 million lemmings can't be wrong. So we get very large reactions. Last year we had about 6 of our telecom crisis management bridges that are brought together anytime we feel like there may be a sufficient threat to the corporation to bring a lot of different expertise together. In all but 2 of those, within a half hour, we knew that this wasn't going to be a problem. And sometimes that's your biggest security thing, to say when you don't have a problem. Even though the media is losing, what's that about when all about you are losing their heads? And really, that's one of the unfortunate things about really good security people. You do your job right, nothing happens. Which is, like I said earlier, that ain't the way to become a hero. Though, I'll tell you also, enough exceptions do occur that you will have plenty of opportunities. So, quick reaction solved it. We knew what they were having. Why? Because we get most viruses as soon as they appear anywhere, take a quick look at them, and can determine fairly quickly what is going to have a real effect or what isn't. That was a direct effect of Melissa. That we had to develop the lines of communications to bring the viruses in early, and there were about 200. Is there a question? He's waving? Oh, okay. By the way, I'm just guessing. I can't hear, so I make a lot of guesses. So, most damage, collateral. But as I've mentioned, you can't avoid it. Okay, why do they work at all? Well, there's a lot of reliance on ignorance. Users don't know about all these patches that go on. Steadily increasing population. We have what is called a target-rich environment. If you can't find one immediately, it's easy to go on. And as we go from 50,000 cable modems and DSL connections to 50 million cable modems and DSL connections, stable targets, fixed IPs, 24/7 operation in somebody's trailer, that target is going to increase. Little understanding of the implications of all the things we have. No, who wants to understand? Who cares? It can send your mail or not. Who cares if it can send everybody's mail? Single universal operator. So if somebody understands how collaborative data objects work in its intended application, they have a really good idea how it's going to work in an unintended application. And that's a dangerous point. Futures? Well, I think the number of discoveries is going to increase. I say discoveries because we have people who do nothing but pound every possible sequence at these programs. Anyone see the dotless vulnerability in Internet Explorer? Where basically, if you took an IP address, which is a collection of hexadecimal values rendered in decimals, which is why 0 to 255, that's really a byte, and you render it as an octal value with a leading 0, Internet Explorer will treat it as local. Now that's kind of like whoever ate the first oyster. Who on earth would think of doing something like that? But at any rate, things that aren't supposed to work that do. Every time a vulnerability list comes out, people will start stressing those vulnerabilities. Well, what else can I do? This is a neat thing. What else can it do? How do you make executable ASCII? How do you make a program that runs on both a PC and a Macintosh or a PC and the Sun? Mr. Morris did it, except then it was a vaccine machine. All you have to do is detect which one you're doing first and put a jump to the other that will be understood by the other at the front. There's some neat tricks you can do with that. Code that is understandable by one machine that is ignored or has no effective effect, or you can fix the effect of later. It's all inherent. 2 machines, relatively easy. 3, very difficult, not for the faint of heart. 4, I'm not sure it's possible, but it may be. It's only impossible until somebody does it. So that's where you get your multi-platform. Vulnerabilities from common APIs for multiple processes. You would not believe how much information about how to do things with source code is on those websites from the vendors. Cut, paste. In fact, I was going to bring it, but I had trouble finding it again. The source code in Melissa can be traced line by line to a CDO sample that was on the Microsoft web page. I've got it at home, I just couldn't find it. I apologize for that. Blurring the protocols. Well, once upon a time we had all these different things that did specific operations. And what we're seeing now is essentially everything's HTTP. One protocol, everybody doing anything you want to do along it. So we've got HTTP and HTML-enabled SMTP. You've got HTTP doing FTP. You can even do Telnet, though crudely. Biggest thing missing is feedback. But if all you're trying to do is spread destruction, you don't want feedback. In fact, you don't want anyone to be able to find out where you were coming from, which is one of the real dangers that exist today. Okay. Increased numbers of I'm not sure if dumb is the right word. I mean, I used to write code that I considered user stupid. It would figure, if you made a mistake, it would figure out what you were trying to do and then suggest that you might really have meant this, not that. But you don't see this anymore. You might say, maybe it'd be better to say ignorant, because ignorance is curable. I don't know if it's going to. Target-rich environment, I mean, what is the critical mass? How many vulnerable machines does it take to get something that will spread explosively? We don't know. As far as I know, there's never been any research done on that fact. We've had some people talk about increased number of binary. Now, what I meant by binary, the tribal flood denial of service was a binary attack. And if you look at a novel by Lewis Theory back around 1993 called Soft War, you'll find mention of a binary attack. Screw up the temperature of St. Kitts and all the printers go berserk. So it's nothing new, but we're starting to see these. And why? Because if you infect a zombie and plant an attack from a zombie, then go away. When the zombie triggers, how do they know where the attack came from in the first place? One of the big things that malicious people learned from Melissa is that it is amazing how far you can trace the original source. So one of the functions of tribal flood was to eliminate that traceability. Okay, movement of online machines from Unix to Windows-based. All the denial of service machines attacked this February were Unix machines, mostly Sun Unix. Why? Because the method of inserting the attack was via a known vulnerability in Sun RPC. And one of the interesting things is that I never once saw mention in the media that, are you worried about being a zombie? Do you have port 111 open? Is that a simple question? Did anyone ever ask it? Did anyone even know it was that simple to detect? That wouldn't tell you if your machine was a zombie. It would just tell you if it had the capability of being exploited as a zombie. And now you reduce the number of machines you have to check down. In my case, the number of exposed machines with 111 open turned out to be 6. I checked them all, closed RPC, none of them were infected. 6 from over 160,000 machines. One of the big jobs of security is reduction to manageable functions, but I never saw that mentioned anywhere. Companies adding firewalls, which are going to be violated by home use of cable modems. Now, how many people have a personal firewall at home? Good. How many people in the real world do you think have them? How many people with BMWs have them? 2. Oh. Sorry. Okay. No, that's a 1967-2002, right? All right. In 1967, Motor Trend voted the BMW the best European sports sedan under $2,000. So there were some. But this is adding the targets, moving targets. Once PPPs were all DHCP. Every time you dialed up, you were liable to get a different IP address, and you weren't connected all the time. These machines are now becoming stationary, fixed IPs 24/7, and how difficult is it to find out at what portion of the IP address space is allocated to Roadrunner? What would you do a search for? Time Warner? How many address spaces do you think you'd get immediately if you just did a NIT lookup on Time Warner? Lots. How many do you suppose are exploitable? How many do you need to find to exploit? 1, 20? That's the thing. They don't find all machines. They just need to find enough. And we'll go from there. Well, with that, we're pretty close, so we've got a couple of minutes. Any questions? Anything I can help you with? Showing? Dancing? I don't do that well anymore. Sir?
I've been talking with some people about the open source operating systems and these sorts of exploits. Will having an operating system with the complete total source code make doing this sort of thing more common or less common?
It will make it easier for those who have time to study it. It will also make it easier for those who have time to study it to secure it. If you understand all of the implications, you know where the holes are. I mean, this is the reason I don't believe in penetration testing, though I usually have a lot of people asking me to do them. I just tell them, well, give me the ACLs of the firewalls and the routers around it, and I'll tell you where the holes are. You can go pound them. But incidentally, one thing a penetration test won't tell you is where the internet islands are, where the spoofable outside DMZ machines are that are allowed holes in the firewall. And does the router block outside addresses on the inside, or inside addresses coming from the outside? The Shimura attack. You'd be astounded how many security administrators never understood the implication of the Shimura attack. And I just lost everybody, right? No, you all know what it is. Use of a machine that should be on the inside, your intranet, that is coming across the firewall in order to flood another machine. That's a Shimura attack Mitnick used against Shimura. And the fact was the firewall didn't think it at all odd that an inside machine was sitting somewhere 7 hops out on the internet. Fun. Questions? More? You all hungry, tired? Pizza night? Sir?
Is Microsoft stuff going to get any better?
Better for what? Depending on what you want to do with it, it's already very good.
Is there going to be any outcry against people like Microsoft from outside the computing community, from insurers or other people who are going to pay for cleaning up messes?
Do the words culpable negligence have any meaning to you?
Yes, that's why I'm asking this.
But they don't to the lawyers.
Okay.
And until the lawyers understand the implications, you won't see anything.
And you don't see that coming?
I've been trying to educate lawyers for over a decade. I consider them a very valuable weapon sometimes. I mean, I still have some sealed driver discs that were infected and being issued by a company, just in case somebody wanted to have proof that that company actually was sending out discs, because the sealing would demonstrate it. But no one was interested. Nobody, you know, one of the most frustrating things to find, how many times have you heard of somebody sending out a CD, sending out program discs that has a virus, and they say, well, our scanner wasn't up to date. You must have all heard that before. Now the question that always has been in my mind, you don't know what's supposed to be on your disk? You know, you're trusting a scanner to tell you what's on there? How come you don't know exactly what the program's on? The reason I get upset about that is I used to design flight controls for aircraft, F-16, F-111, back when I had a real job. And every time we were running tests out at Edwards Air Force Base, better known as Muroc, when you could drive fast cars there. But I was in Texas at the time, and we had to send the flight control software. And I used to do two things. People kept saying to me, why are you doing that? One was, every time I sent out a new piece of software, I sent it 3 times. I got that from, anyone read Heinlein? Tell me 3 times. Well, the F-16 happens to have triple redundant flight controls. And the last computer happens to be under the pilot's seat. Can anyone guess why it's under the pilot's seat?
So if the plane is shot to pieces?
Yeah, you got a 20 millimeter cannon shell there. You really don't care if the computer failed. But I would send it 3 times, and I would send it with cryptographic checksum so it could be verified that what you received was what I sent. And before loading it, they'd call us up on the telephone and verify the checksum. And people thought, why are you adding all that? And I used to have the simple explanation, well, if we make a mistake, somebody else makes a big smoking hole in the ground. And it was effective. We never had a single software-related aircraft loss. Sir?
Did you catch any problems that way?
Did you catch any problems that way? Did you catch any problems that way?
Well, what we caught a couple of times was that one of the 3 copies didn't come through properly. And then we just go to the backup. That occurred several times. We never had the instance that incidentally was used in a couple of novels, and I remember chuckling about it. Stephen Kuhn's Minotaur, when he was talking about getting an outdated program, we never had that because the cryptographic checksum wouldn't have matched. But I guess novelists are permitted artistic license. Then again, maybe nobody else was bothered, and that's why F-22s kept flipping over. But I shouldn't knock competitors. Anyone want to buy an F-16? We got some. There.
I'd like to buy an F-16.
Okay. Creative financing can be arranged. Yeah.
Well, thank you very much.
Oh, man.